Hello and welcome to this webinar on unlocking Chile's green hydrogen export potential. So today we'll have two experts who will be talking to us about this, with us about this subject. And before we do that, I'd like to just make a couple of remarks about how this webinar thing works. So some of you know us very well. So and you know that we always encourage you to introduce yourself using the chat function. So please do that. We are recording this session, and you will get, if you signed up, you will get an email to with a link to the video recording and also to the presentation slides. And and the last thing I want to say before I give the floor to our speakers is that you can send questions. And for that, you have the Q&A box, which is at the toolbar at the bottom of the screen. And yeah, so that's enough of me for the time being. So I will now ask our speakers to introduce themselves very briefly. Then we'll have the presentations, and finally we'll open the floor to questions from the audience. So okay, so welcome Francisca and Alvaro. I hope you are both well today, and we're happy to have you here. So let's start with Francisca, actually. If you could please tell us who you are.
Well, my name is Francisca Gallegos. I'm a Chilean lawyer, and also currently I'm doing my PhD on hydrogen certification mechanisms in the University of Eastern Finland. And I'm a part of the RISA project, that it's a project founded by the European Commission that involves 3 universities around Europe. And well, we are trying to develop the hydrogen regulatory framework for Europe to enable international trade.
Thank you very much, Francisca, and welcome to today's webinar. And Alvaro, please introduce yourself briefly as well.
Thank you very much, Carlos, and thank the team and the organization for inviting me here. Name is Álvaro Pérez. I work as manager for AFRY Management Consulting. I'm an energy engineer, and within AFRY, I've been actively involved in the development of the hydrogen practice, as well as in Spain, as well as in Latin America, and Chile, Colombia, and Peru.
Brilliant. Well, thank you, Alvaro, for the introduction. And now I'm going to stop sharing my screen. And Alvaro, whenever you're ready, start sharing yours so you can begin your presentation.
Thank you very much. Let me share my screen. You should be able now to see my screen. Please let me know if.
Yes, I can see your screen. Yeah.
Okay.
So over to you, Alvaro.
Thank you very much. So today I'm going to talk about Chile's hydrogen potential. Well, not only hydrogen, but also hydrogen and derivatives export potential. So let's move on to the matter. Just a very brief introduction about AFRY. In addition to what I said, as I said, we are a consulting firm specialized in the energy sector. Few years ago, we opened the hydrogen practice. Since then, we've been actively involved in several hydrogen-related projects in Europe, as well as in other regions. There you may see some figures about our activity in the last years, and all the potential, all the activities, all the projects that we've performed and we can perform. But now, if we move onto the topic of interest today. So talking about Chile's hydrogen potential as an export country, it's important first to know where are the key regions and which will be the key players where Chile will be able to export. In order to do that, in this slide, we summarized the 5 key regions that have announced very ambitious plans about hydrogen development as well as hydrogen imports. So if we go from the first one, the United States, as most of you already know, last year released the IRA, where it contemplates an ambitious program to develop domestically the hydrogen production. In this term, this program aims to provide support to hydrogen projects up to $3 per kilogram. This is a really ambitious program. And nonetheless, it is true that the United States is expected to be, let's say, a self-producer of hydrogen. So despite there might be opportunities, obviously, for export countries, we expect that probably the US will be a net, let's say, self-consumer, self-producer. On the other hand, we have other regions such as the European Union, Japan, and South Korea. Especially the European Union, as most of you know, has done an extensive work in terms of hydrogen regulation, in terms of green hydrogen definition. So currently, the European regulation defines very clearly what is or what they consider renewable hydrogen or RFNBO, what they consider low carbon hydrogen. It is really clear defined how or what are the conditions, the additionality principle, the temporal and geographical correlations in order to define renewable hydrogen. And it is also very clear the methodology to calculate CO2 emissions and the CO2 content in the hydrogen in order to certify this hydrogen. Beyond that, the European Union released a very ambitious program, in particular the REPowerEU, where it stated that by 2030, they expected that 20 million tons of hydrogen will be consumed in the EU. And half of it, and here is the important part, will be supplied through third-party countries, so non-European countries. So here, the European Union sent a very clear message to the world that they intend to import hydrogen from other regions. And here is where we see clearly that Chile might play a very relevant, a very key role, as we will see in the following slides. With regards to Japan, South Korea, they stated for a different approach in terms of hydrogen definition. I won't enter into too much detail. They are more worried about the CO2 content rather than the specific definition of renewable hydrogen. Nonetheless, they've also stated and released ambitious programs in terms of hydrogen consumption, also including and considering imports, as you might see there on the slide. Finally, China, the country has done and has a very extensive knowledge in terms of technology. They are they are expected to be one of the big electrolysis producers worldwide. Nonetheless, in this case, we expect, let's say, a similar case to the US, where probably the country will be a self-consumer, self-producer of hydrogen. So now, if we move on to the next slide, once we've set up the scene worldwide, another thing that I'd like to mention and detail before entering into Chile's potential is, let's say, what is the size of the market, or what is the potential size of the market for renewable hydrogen. So there we have some numbers from the IEA about the expected global hydrogen demand by 2030. As you might see there, there's an expected 150 million tons. From that, 34% will be electrolysis. And from that, as you might see there, the three key regions are the already mentioned. So the EU, the US, and obviously China, Japan, and Korea. This is, I just wanted to start by here to set the scene, set what will be the potential targets for Chile and what will be the potential market and demand that Chile might target. So now if we move on to Chile, how Chile can compete in this worldwide world, in this world of hydrogen. So if we are talking about renewable hydrogen, the first thing is to see what are the renewable resources that Chile has available, no? And here we've plot the solar and wind load factors for different countries, and we've highlighted in red where Chile stays. So one important comment here is that Chile has both great potential in terms of wind and solar. And if we consider the production of renewable hydrogen only with renewables, this automatically places Chile in an optimal position to produce this hydrogen at very competitive prices. One comment here, or let's say one challenge that Chile must overcome here is to the integration of all these renewable projects or potential into the grid. As probably many of you know, currently Chile is facing problems in terms of transmission assets. There are a lot of development and upgrades ongoing in Chile with regards to transmission development. And in order to effectively achieve the full potential of renewable production in the country, it will be key to develop a very reliable and resilient electricity network that might allow the integration of renewable. This is because in many cases, the hydrogen project cannot be or won't be able to be located where the wind and solar resource is available. So the electricity will be needed at that point. So with that in mind, we wanted to show in the next slide how or what is the potential competitiveness of Chile against other countries, other peers, especially in Latin America. So here we've computed a slide calculating the LCOH per country. We've normalized the values to show how they compete against each other. So just to explain the slide, if we go to the right side, to Germany, we will see Germany as the, let's say, the region, the country with the highest cost. So that is assigned 100%. And then we move on to the left as a comparative value against these Germany's. So there we can see that starting on 2030 and continuing on 2050, Chile might be one of the cheapest producers of hydrogen. Nonetheless, as you might see by the color code, we understand that currently, given all these problems with the transmission network, hybridization of projects in Chile is a major challenge, and this will prevent many projects from being able to hybridize between technologies. So one bigger improvement that might happen in Chile if a network is developed is that a hydrogen project will be able to hybridize between technologies, will be able to increase the load factor and the hydrogen production, and therefore they will be able to reduce, to optimize even more the competitiveness of its hydrogen production. Taking into account that if we only consider solar production as the main supplier of the electrolyzers, Chile can still be one of the biggest competitors worldwide. So just finally, as a conclusion to sum up here, we wanted to provide some numbers about the local market. This is because we believe that in order to become a good, let's say, a solid exporter and a key player worldwide, it is important first to have local demand, because first projects in any country will be dedicated and can only be enabled if they attend local demand, and then based on that, take that advantage to develop, to construct, to build a solid export infrastructure that allow the country to become a net exporter of hydrogen. So according to IEA report, 2019, the hydrogen demand of Chile was around 200 kilotons. And if we turn that into a renewable capacity and electrolyzer capacity, we're talking about 1.5 gigawatt of electrolyzer and 2.3 gigawatt of additional renewables to supply these electrolyzers. That turns into investments of around 3.5 USD billions. And again, and as I said, especially relevant for Chile, all the grid reformers required to supply the electrolyzers. So I would say as a final conclusion about my presentation that Chile has the potential to become one of the most competitive hydrogen producers worldwide. It has an excellent solar resource. It has an optimal wind resource. The challenge, again, is on the electricity grid integration. And there, the role of the country to develop strong, resilient, and reliable networks will be key to optimize hydrogen production and to, let's say, turn the country into a world-class exporter. Thank you very much.
Thank you, Alvaro, for your presentation. If you have any questions for Alvaro, please post them on the Q&A box, and we will get do them after the next presentation by Francisca Gallegos. So, yeah, if you could stop sharing now. Thank you very much. Alvaro and Francisca, over to you. You can start sharing and begin your presentation. And just in the meantime, I'd like to remind you that we are recording this session and you will get an email with the video recording and the slides in a few days. Over to you, Francisca. Oh, it's gone out of...
Can you hear me now?
I can hear you, yeah.
Yeah, perfect. Today I will talk you about like the basics of hydrogen, and then we'll introduce to the regulatory framework internationally. First of all, what is hydrogen and why it's important for decarbonization targets? First of all, hydrogen is the most abundant element in our universe. It's everywhere. And commonly, it's attached with other elements. So to obtain its pure form needs to be produced, needs additional energy to break down its molecules. And why the world wants hydrogen now? Because hydrogen has a special advantage that does not release CO2 upon end use. And this will mean a reduction of distributed emissions. Hydrogen also has a versatile nature. It can serve as an energy carrier or feedstock, can be stored, the renewable energy, and also will help us to decarbonize hard-to-abate sectors like industry, heavy transport, steel, among others. Well, once we split the hydrogen molecule, we can add other molecules as carbon or CO2 or nitrogen to produce e-fuels. As for example, we have ammonia, methanol, e-methane, e-kerosene, and e-diesel. The main advantage of these e-fuels is that they can use the actual infrastructure. For example, the combustion engines like cars or trains actually today can use e-fuels as e-kerosene with the possible point that they are carbon neutral. So There's different ways to produce hydrogen depending on the process, technology, and energy source used. Today, the most common and affordable way to produce it is from fossil fuels, mainly natural gas. And we can say that currently around the 95% of the hydrogen produced in the world comes from fossil fuels, and only the 5% comes from renewables. None of these production methods is easy, but all of them got pretty colors. Here, I can explain, we can see the two main production methods from fossil fuels, mainly is from natural gas, and they use the technology as natural gas reforming. And we have gray hydrogen that release CO2 into the atmosphere. We have blue hydrogen that use the same technology, but they use carbon capture and utilization of the CO2 release in the production. And on the other hand, we have the production method called electrolysis that use electricity to split the water molecule. And depending on the power source of the electricity, we have green hydrogen that use renewables, purple or pink hydrogen that use nuclear source, and yellow hydrogen that use the electricity from the grid that combines fossil fuels and also renewables. Despite the diverse force that hydrogen can be produced from, the end product itself, the hydrogen molecule, does not enable identification of its origin. All hydrogen molecules are the same and are identical, and taking into consideration that the different production methods have different emissions footprints, they vary considerable from one to another. While hydrogen is often labeled through colors to represent the technology used to produce it, this classification alone cannot fully quantify and describe the emission impacts of the production methods of hydrogen, nor does it allow to meaningful comparison between them. Therefore, there's a need for reliable tracking instruments that help us to track the sustainability attribute through the whole value chain. A comprehensive understanding of the emission impacts of hydrogen is essential to attract investment and can form the basis of a robust regulation. One way to track the sustainability attributes of hydrogen is through certification. Certification actually is my research topic, so I'm very glad to have the opportunity to talk a little bit about it. This certification process it's a process in which a third independent part audits all the process of production, transportation, and distribution of hydrogen, assuring that the end product meet the regulatory requirements or criteria. As a result, a certificate will serve us to differentiate this product from others that has lower sustainability credentials. Here we can see that there's different elements in the design of the certification. These vary widely in the international world today, but we have common elements. For example, the scopes. If they refer only to hydrogen or they include derivatives, the emission threshold, what is the range of kilo of CO2 allowed per kilo of hydrogen produced, the production methods, the emission accounting that refers to the methodology used to account these emissions, the boundaries, if they cover just the production or the transportation, or also the distribution and to the end use, and the change of custody. The definitions, internationally, the definitions of green, low, or clean hydrogen depends on the production methods, but also depends on the criteria set out in the different jurisdictions. Today exists a variety of different standards of what is the meaning of clean, low carbon, or green hydrogen, depending on the country. Here we can see this list that it was made by the International Renewable Agency, IRENA, and they compare, and we can see that the criteria for certifications vary widely. For example, in the United Kingdom, the emission threshold for the energy sectors is 2.5, while in the European Union is 3.4 kilos of CO2 per kilo of hydrogen produced. And for example, in China, low carbon in China is defined of 14 kilos of CO2 released per kilo of hydrogen produced. So we can see that these vary widely. And this lack of consistency raised concerns about the comparability across international borders. So what we want to create an international global hydrogen market. But to ensure this effective interoperability at international levels, we need a common approach that at least include a methodology for determining emissions that includes emission intensity, system boundaries, scope, chain of custody, and production methods that will allow to create an international hydrogen market that today doesn't exist. This will help to encourage investment, facilitate trade, and promote the use of sustainable hydrogen. Here we'll talk about the international hydrogen strategies. To the date, we can see that at least 60 countries has published or are drafting hydrogen strategies. But most of them, they are aiming to establish themselves as an exporting country. On the other hand, we can see that the potential importers of hydrogen today, according to their hydrogen strategies, are South Korea, Japan, and the European Union. And as exporters, we can see that Australia, USA, and China, for example, they have released their hydrogen strategy, but they also have a regulatory framework promoting the creation of the hydrogen market in there, giving financial incentives to the clean production of hydrogen. At Latin America level, we can see that Brazil and Argentina have published last year, has enacted a hydrogen law to promote their industry. But Chile, we don't have that law yet. And we can also see that other regions in the world, like Namibia or South Africa or Oman, have already developed this structure in their regulatory framework. Well, what's the potential of Chile and what are the key challenges? Well, we have to admit that we have a comparative advantage and potential for generating renewable energies with extraordinary levels of efficiency. This can be translated into lower production costs. We can see that in 2022, the Chilean electricity national grid has the 58 renewable share. That's a lot if you compare it to other countries. So what we need to do today? First of all, we need to take advantage of the renewable capacity that Chile has and adopt concrete measures to design and implement instruments that help us to promote the technology development. We also have financial incentives. On the other hand, we also need a public and private coordination to reduce barriers, increase the generation capacities, scale, increase the transmission grid and infrastructure. Other element that we need to take into account is to face the challenge of transporting and storage of hydrogen in Chile. We need to create the networks. We need to build capacities that requires large investments. Therefore, Chile really needs to regulate and promote and give financial incentives to the production of green hydrogen. Why this is important? This is important because if we want to export clean hydrogen from Chile, we need to comply with the regulatory requirements set by the importer countries. And here I can explain, I use an example of the European framework that exists today, that is one of the most advanced in the world. So if we want to sell hydrogen to the European Union, we need to comply with these requirements. First of all, the regulatory framework of renewable hydrogen, it sets in the Renewable Energy Directive and its delegated acts. They give you a definition of what needs to be understood as renewable fuels of non-biological origin or renewable hydrogen in Europe. This Renewable Energy Directive also give a calculation rules of what needs to be understood as renewable hydrogen production. The purpose of this regulatory framework is to define what is renewable hydrogen in the EU and what needs to be in compliance with importers and also producers inside the EU to have a price premiums or higher prices in the hydrogen. So this regulatory framework is complemented by two delegated acts that define what is RFNBOs and what's the method of calculation of the emissions through the whole value chain. Well, we can see that the first delegated act refers that hydrogen production needs to be made from renewable hydrogen, renewable electricity, sorry, and provides three cases where it's a direct connection between the renewable electricity facility and the electrolyzer, where the second case is when there's grid connection, and the third case is when it's a grid mix. Actually, there's like very complex rules regarding this, and I don't think we have time to explain it in details, but I will provide you the key principles that rules this delegated act. First of all, the additionality. The additionality refers that the hydrogen production should add to the deployment of the renewable energy share to incentivize an increase in the volume of renewable energy available. Then the temporal correlation, that means that renewable hydrogen should be produced when renewable electricity is available. And third, geographic correlation. That means that there should be no grid congestion between the place where renewable electricity is produced and the renewable hydrogen is produced. In a nutshell, hydrogen is considered RFNBOs when additional electricity is produced at the same time and at the same area. Second, the second delegated act refers to the emission savings of the GHG emission savings. So the RFNBOs needs to comply with the 70 GHG emission savings threshold. That means 3.4 kilos of CO2 per kilo of hydrogen produced. And here we can see that the first delegated act covers only the production method, the production phase of hydrogen. But the second delegated act covered the transportation and distribution. So these 3.4 kilos of CO2 per kilo of hydrogen produced need to take account the whole value chain. For example, if Chile wants to produce renewable hydrogen with zero emission in the production, we need to vessels or ships that will transport the hydrogen with low emission to comply with this emission threshold. Thank you for your time, and let me know if you have any question.
Thank you, Francisca, for your presentation. So we do have a few questions here. So if you can stop sharing, then we can. Thank you very much. We can start. No problem. We can start answering some of these questions. So let's have a look at some of the questions that we have here on the Q&A box. So okay, so let's go with this one. Carlos Moran Pontla asks, what would be the MVP at the moment to develop for green H2? So the most valuable player for Latin America. The MVP, I know that's most valuable player from my years of watching baseball, but I don't know. So the best country, right? So I think Álvaro, you had you said you wanted to reply to his question. So over to you to start with.
Thank you very much. I will assume the same as for MVP. So as I saw in this slide during my presentation, I think that Latin America in general is a great region in terms of renewable resources, but especially Chile, Colombia, and Brazil will be best placed to become good exporters of hydrogen. All three of them have released the hydrogen roadmap. All three of them have great ambitions in terms of hydrogen productions. All three of them have, let's say, a relevant demand, domestic demand, to build on that additional export infrastructure in addition to it. And however, as I say, all three of them have different challenges. As for instance, for Chile, I mentioned the grid. Colombia, on the other hand, has other challenges starting by developing renewables or large amounts of renewable projects to supply electrolyzers. But I would say those three are in the best position.
Thank you, Álvaro. Francisca, I don't know if you want to add to this answer.
No.
No? Okay. Thank you. So, right. So, there is one question here which I think makes a lot of sense. You know, it might seem obvious, but how do you export hydrogen from Chile, given where it's located globally. So Eduardo Baruel asks, how do you export hydrogen from Chile to the world? Chile is far away from most places. So what can you say to this?
Well, actually, the most affordable way to transport long distance transport of hydrogen it's through e-fuels, mainly ammonia today, but we can see that methanol has increased lately. Their projections, and we can see that the hydrogen produced needs to be converted into e-fuels to transport it in a vessel or ships, and then need to be converted in the port again into hydrogen to be used, or also can be used as e-fuel.
Thank you very much, Francisca. I don't know, Álvaro, if you have an answer to this, or if you'd like to add to this, your answer to these questions. So how can you export hydrogen from Chile to other countries?
No, I totally agree with Francisca. Ammonia and methanol, let's say, are the most acceptable alternative. I would only add one comment is that it is true that Chile might be probably remote from many regions, many countries, but it's important to take into account that most of the cost of the transportations are related to the conversion of hydrogen into ammonia and methanol. So let's say the variable part or the distance cost, talking about hydrogen transportation or hydrogen derivatives, let's say it's less relevant than the fixed cost of converting hydrogen into the ammonia, let's say.
Thank you, Álvaro. And there is a question here for you, Álvaro, which is by Jose Figueroa, and he asks, AFRY studies compare LCOH place somewhere in Europe. No, actually, I think there was another question of, yeah, that one. So essentially, what are the basis for your LCOH comparison? And there is another related question, which perhaps you could, by Tony Matar, which you could answer at the same time, which has to do with the electrolysis technology that you use, that you model for. Was it PEM or alkaline?
Okay, thank you very much. So for the first question, the numbers we showed referred only to LCOH production. So we were not including transport costs, so it's local cost, let's say. One additional disclaimer or comment is we only take into account, let's say, the LCOE of the renewable technology supplying the electrolyzers, so namely wind and solar. So no grid cost is taken into account either in that analysis. With regards to the technologies, we assume, let's say, a mix of PEM and alkaline, depending of our internal view of the evolution and the cost of these technologies. So just to provide a bit more of context, so by 2030, we expect that the dominant technology will be the alkaline. Since it's a more mature technology, we expect, let's say, more competitive cost for this technology. Whether for 2050, we expect that there's room for improvement in terms of PEM technology, and we expect by 2050 that PEM will have gained market share.
Thank you very much, Álvaro. And a question for Francisca. So Darren Lederman asks whether this effort to create a standard to measure the carbon intensity of hydrogen, or what does it mean to have green hydrogen? Is it a complementary effort to what the International Tracking Standard Foundation, formerly known as IREC, is doing?
Yes, well, what IREC is doing is like it's the same that various organizations are doing today. And the main problem is that we don't have a common methodology. I would say that today, actually last year in the COP28, the International Standard Organization has launched their methodology to the emission assessment for hydrogen production. And I think that can be a way to standardize the different certifications and standards that exist today. But we need the commitment of governments and countries to use the same methodology.
Thank you. Thank you very much. And how is that progressing? So are we anywhere near seeing like a standard that could be applied elsewhere? Or I mean, when could we expect a standard that will be adopted in most places?
Well, I think we are getting closer because like every country or jurisdiction have their own regulatory requirements and emissions methodology. But in the last COP28, where the ISO standard was launched, there's a commitment between different countries. I think more than 40 countries signed a letter of commitment to use this methodology, but it's not legally binding. So we cannot know, or we don't know when we'll achieve an agreement on common methodology.
Thank you, Francisca. So one of the things that Álvaro mentioned in his presentation is that you need a local market to get things started, and then you could become an exporter of hydrogen products. So Raquel La Sierra asks, so is there a local market for renewable hydrogen in Chile, and who could be the main off-takers in the country of renewable hydrogen or derivatives of hydrogen? So Álvaro, do you have a view on this? So what could be the main users or the main off-takers of renewable hydrogen in Chile?
Yeah, thank you. So yes, as in many cases, the first movers here are the oil and gas companies. They already have hydrogen consumption as feedstock to produce, let's say, all derivatives. And that will be, or that is the case for Chile too. So most of the current hydrogen demand that I showed on the slide comes from the oil sector, from refineries, basically. The other, let's say, main sector that currently consumes hydrogen is fertilizers. To a lesser extent, there's also a demand in Chile for this. And in addition to that, we've seen that other sectors that are taking the first step, and another sector where we've seen that, let's say, projects are taking FID is the steel sector to produce green steel. So that could be, let's say, like an additional potential source of hydrogen consumption.
Yes, I would like to add something in this point.
Please,
that like recently, less than 2 months ago, the International Renewable Agency have said that the Global South, included Chile, need to be focused on the internal demand first, and then create a market to be an exporter. So it's really necessary to create internal demand. I would say, as Álvaro said, hard to abate sectors as steel, fertilizers. Also, Chile has a huge industry of copper. Also, heavy transport can be a good start point.
Thank you, Francisca. And talking about the but the exporting side of things. So someone asks, although I can't find the question, but someone has asked whether the Chile has the port infrastructure to export ammonia. Or the person asked whether there is a port infrastructure ready, or whether it could be sent through a pipeline to a neighboring country for export. So, do you know about this? So, either of you about the state of
Well,
Patrice Horner. Yeah, that's
I would say that Chile needs to build the infrastructure now. And actually, the gas networks that already exist in Chile are like so small, and they connect to Argentina, but to transport, you need to transport through whole Argentina to get to Atlantic. So we need to build the infrastructure, in my opinion.
Yeah, no, here I agree with Francisca. In addition to that, despite the upgrade on the gas network and on the ports, it's important to take into account that if we assume that ammonia will be, let's say, the key derivative or the main form to transport hydrogen, ports need to be adapted to handle this gas. It is not straightforward. So there are already obviously ports that can handle ammonia, but it's not the case for most of it.
Thank you. There was a question on whether in the European regulation, this was thing addressed to you, Francisca. If yes, I found it. So Deepak Balachandran asks regarding RFNBOs, are fuels produced from biomass at any disadvantage?
Actually, yes, they are, because the definition of RFNBOs expressly exclude as biomass as a source to produce RFNBOs, but in the hydrogen and gas package that covers low carbon hydrogen in the EU regulation, biomass is included as renewable gas, but not as RFNBOs.
Right. Okay. So yeah. So you couldn't. So you can, I suppose, produce like biomethane, but not use the biomethane to produce.
Yeah, because as Álvaro said in its presentation, Europe has set out like different targets for RFNBOs for the importing and internal production, and probably they'll get a premium price in the market, but just for RFNBOs, and those RFNBOs are renewable hydrogen, but biomass is expressly excluded from this list.
Right. I see. Okay. Well, there you have your answer, Deepak. So there is a question here that comes up in quite a lot of these conversations, and it's by Douglas Pollock, and he asks, if continuous production of green hydrogen is intended, then the electricity must come from the grid. So, essentially, if stable production is required, is there an alternative to drawing electricity from the grid? I think, Álvaro, you wanted to answer this question, so.
Yes, thank you very much. So I mean, I agree with the statement, and now going into the question. So if we require more electricity to produce hydrogen, at some point we will need thermal production. The point here, or the problem here, is that, for instance, according to EU regulation, this is really difficult to include, since hydrogen needs to comply with certain CO2, let's say, threshold. However, and here I want to stress let's say, the importance of other technologies beyond, let's say, typical renewables, wind and solar, we will need electricity systems to adopt storage, mostly in the form of batteries, which they actually match pretty well with solar production. But also, we should not forget pump storage technologies. So, answering to the question, the alternative is to develop an electricity system that obviously is mostly formed by renewables, wind and solar, since those are the cheapest sources of technology in combination with all the available hydro, of course. But to complement, to provide a security of supply, to provide reliability and resilience to the system, we will need in the electricity systems the development of storage, and we will need batteries to come online.
So actually, our event that we're organizing in Chile has to do with green hydrogen and energy storage. So there are a few questions about whether Chile is building up its renewable capacity. Why, if the capacity is only 56%, if they're building up, and that's the plan. The plan, correct me if I'm wrong, Francisco, Alvaro, but I think the plan is to get all of the electricity from renewables by 2050. Is that right? Yeah, okay.
Well, Chile has committed to the carbon neutrality by 2050, but that doesn't mean that the electricity will be 100% renewable.
Yeah.
That only means that the carbon neutrality will be reached, or we want to reach that by 2050.
And then you get into interesting accounting exercises, right, as to what means to be neutral. But I mean, in any case, the renewable capacity is meant to expand, and there is a plan to retire coal capacity as well. So yeah, that is happening, and there is supposed to be quite a lot of storage as well. So yeah, that is in the works. Yeah, just wanted to ask a few questions on the go. So we have a couple of minutes left. I don't know if there are anything that you'd like to mention to the audience before we leave? Any parting words? Go on, Álvaro.
No, from my side, that's going to say again, thank you to you. Let's say insist on the importance in the case of Chile to improve the electricity network, to integrate all the renewables, and here talking again, batteries and storage might play a very relevant role, not only obviously for hydrogen, but also to provide security of supply to the grid. Thank you.
Yeah.
Francisca.
And I also want to say thank you for having me here, and to just say that like Chile needs to use their potential now, like, because otherwise we can left behind. Like we can see that Brazil and Argentina have enacted a regulatory framework promoting the infrastructure, the financial investment that we need to develop the market, and Chile needs to be or need to do this now, because otherwise we'll pass.
Yeah, thank you very much, Francisca and Álvaro, for your presentations, and thank you to everyone who was online today to watch this webinar. As I mentioned, we have recorded the session. We'll send you the video recording in a few days, and also the presentation slides. So, well, if you like these sort of content, so you can always find more on our website, which is atainsights.com. And if you are really thinking of investing, or are already investing in Chile, in Chile's green hydrogen market, then consider coming to our event. So you can see the that we have here, Rainmat Chile, which is coming up at the end of July this year. So thank you very much, and to all of you, and have a wonderful afternoon or morning, depending on where you are from. See you next.